So today's lesson is lesson 68, compounds probability. So do now is complete the following problems. A. Use a tree diagram to find the sample space. So the spinner is spun. So it's trapezoid, parallelogram, rectangle, rhombus, square. And a letter from the word math is chosen at random. So you could have trapezoid, parallelogram, rectangle, rhombus, or square, and then one letter from the word math. So M, A, T, H, M, A, T, H, M, A, T, H, M, A, T, H, M, A, T, H. So those are all the possibilities that you could have. So the sample space would be TM, TA, just everything we have here. TT, TH, PM, PA, PT, PH, RECM, RECA, RECT, RECH, RHM, RHA, RHT, RHH, and SM, SA, ST, SH. So that's the sample space. B. Use the counting principle to find how many 5-digit zip codes are possible. So you could have 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 as your digits. So that's 10 digits. And then 5 of those digits. So 10 to the 5th power. 10 to the 5th power gives us 100,000. So there'll be 100,000 different possibilities. Compound events. So compound events are the probability of 2 or more simple events. So the first one we'll talk about is independent events. So in independent events, the outcome of one event does not affect the outcome of the other event. The probability of 2 independent events is found by multiplying the probability of the first event by the probability of the second event. The first event is replaced after it has occurred. So if I take something out, then I put it back in. That's replacing it. So 1A, these are all independent events. What is the probability of rolling a standard die twice? So it's going to be 2 times you roll it. And getting an even number, so it would be 2, 4, 6, so it's 3 times, because a die has 6 sides, and then a 5. So there's only 1 5 on a dice, times 6. So 3 6 times 1 6 would be 3 over 36. And if you simplify and reduce that, that's 1 over 12. B. What is the probability of tossing a coin 3 times and getting tails each time? So you're going to toss it 1, 2, 3 times. And your denominator is how many sides there are to a coin. There's 2. How many of those sides are tails? Only 1. So 1 times 1 times 1 is 1 over 2 times 2 times 2. It's 4 times 2, which is 8. So now we're going to use these spinners in the middle. If the spinners are spun once each, find the probability of getting an 11 and then a red. So you need to figure out how many portions are here. So there's 12 in the first one, times how many portions are in the second one. There's 5. How many of these are in 11? Well, there's only one 11. How many are reds? There's only one red. I'm sorry, there's 2 reds. And you multiply. 2 times 1 is 2. 12 times 5 is 60. And divide both by 2. Get 1 over 30. D. If the spinners are spun once each, so it's going to be 2 spins, find the probability of getting at least 3, so it's 3 or more, and then blue. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry. So 10 out of 12 times how many of these are blue? 1 out of 5. So multiply. 10 times 1 is 10. 12 times 5 is 60. Divide both of these by 10. You get 1 over 6. If a card is drawn randomly from a deck and then a date in June is chosen at random, what is the probability of getting an ace, then an odd? Well, in a deck of cards, there's 52 cards times how many days are in June? 30. How many aces are there? There's 4 aces in a deck of cards. How many odd days are in June? Well, half of them would be 15, so we're going to multiply. 4 times 15 gives us 60. 52 times is 1,560. Now let's see if we could simplify that. 60 divided by 1,560. Convert that back to a fraction. So it'd be 1 over 26. And F. If a card is drawn randomly from a deck and a date in June is chosen at random, find the probability of getting a spade. So in a deck of cards, still have 52. And in June, it's still 30 days. So a spade is one of the suits. This one right here is a spade. So there's 4 suits. So you would do 52 divided by 4. So there'd be 13 spades. And a multiple of 4. So we have 4, 8, 12, 16, 20, 24, and 28. So that's 7 dates. And now we're going to multiply. 13 over 52 times 7 over 30 gives us 7 over 120. Now we're going to talk about dependent events. So in dependent events, the outcome of one event affects the outcome of the other event. So the probability of 2 dependent events is found by, so again, we're going to multiply the probability of the first event by the probability of the second event after the first event has already occurred. So the first event is usually not replaced, so it's going to change a little bit now. So 2 says, let's look at some examples of dependent events. So we're going to use the following scenario to answer questions A through D. So there are 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a box. So a marker is drawn, not replaced, so you don't put the first one back, and then another marker is drawn. So let's figure out how many total markers there are to begin with. So 3 plus 6 plus 4 plus 12 is 25. So I'm going to write it here, 25 total. So the probability of getting a red, so there's 4 red, yeah, 25 times, now this is where it's going to change. If I take that red out, I don't have 25 markers left, I have 24. And how many of them are blue? There's 12 blue markers. So 4 over 25 times 12 over 24 gives us 2 over 25. So the only difference is the denominator is not going to be the same. Even though there's 25 total, I take one out and I don't put it back. B, the probability of getting a yellow. So there's 6 out of 25 times green. 3 out of 24. So 6 out of 25 times 3 out of 24 would give me 3 over 100. C, both blue. So if I pick a blue marker, there's 12 out of 25. Now if I take that blue marker out, I don't have 12 still. Now I have 11, and I still have 24 once I take that one out, since it's blue. So it's going to be 12 over 25 times 11 over 24. You get 11 over 50. So I take that blue marker out. So 12 minus 1 gives me 11. 25 minus 1 gives me the 24. Now we're going to do the same thing, but with yellows. So we have 6 yellow out of 25 to start. Now if I take a yellow out, I just subtract 1. So 5 out of 24. So 6 over 25 times 5 out of 24 gives us 1 out of 20. So that's the probability of getting both yellow. So now we're going to go to E and F. They don't have to do with the markers. A bag contains 16 lottery balls numbered 1 to 16. A ball is drawn, not replaced, so we're not putting it back. Then another is drawn. So we're going to find the probability of getting an even. So 1 through 16, half of them would be even, times. So if I pull that even, I'm not putting one back. I'm still going to get 8 odds, but there's only going to be 15 balls now, because I took one of the evens out. So 8 over 16 times 8 over 15. It'd be 4 over 15. And then still, same question. A bag contains 16 lottery balls, numbered 1 to 16. A ball is drawn, not replaced. So again, we're not putting one back. Then another is drawn. What's the probability of getting a 10? Was only 1 10 out of the 16 times. And since 10 is an even number, there's only going to be 7 left out of the 15. So 1 out of 16 times 7 out of 15 gives us 7 out of 240.